here's how to create a SNAIL CAM using parametric modeling. All right. So you might be thinking, what does that word mean? Parametric modeling. Well, instead of making what we call geometric constraints, which define the relationships of different lines, points, curves, etc., to each other, parametric constraints are essentially mathematical kind of relationships, all right, equations. And so what we're going to start with, actually, although this looks kind of boring, is we're going to go to this modify panel and find change parameters, okay? Because in the end, what we want to create is, I've got it right here, all right, this SNAIL CAM, all right? And the directions for this are, of course, on my PLTW 8.1, all right? So I have blown up the sketch so I can kind of see what dimensions it has here. And if you remember, D means the nominal diameter of the cam, all right? And that's typically 1 inch, 1.5 inch, 2 inches, 2.5 inches. If you do 3 inches, they're probably a little too big for our automata. But yeah, so those kind of numbers. And then these are those essentially kind of parametric equations, right? They're relationships to D, the nominal diameter, okay? So we're gonna lay those out before we do anything else, all right? So we're gonna go back to Fusion360, my new thing here, and we wanted to go modify, change parameters. So we wanna set up some user parameters, okay? First, let's put the name. So we're gonna call the first one just D, and that's gonna be the nominal diameter. Inches is fine as our unit. If you wanted, you could make it this unitless, no unit thing, but inches is fine for what we're doing. D is just gonna be 1, okay? So D is D, essentially. And our comment is nominal diameter. All right, so that's that. The next thing I want to do is I have to look, and so I'm going to try to give you some tips that would help with making any kind of shape parametrically. I'm going to look back at my sketch and say, you know what, I need some dimensions that are in relationship to D. Well, one is going to be 1/4 of D, okay, and the other is going to be half of D. All right, so I'm going to create those dimensions. Or parametric parameters. All right, so go back to Fusion360, go here, and we're gonna call this one D0, okay? So D0, also in inches, is going to equal 1/4 of D. All right, so 1/4 times D, and we're gonna say this is the least displacement. All right, so imagine if there's a follower on top of this. At this point, that's going to be the very lowest it's going to be as far as this follower moving up and down as this thing rotates, okay? So least displacement, say okay. The next one I want to make is going to be this half D, all right? So we're going to add another one. We're going to call this D1, and we're going to say this is half times D, all right? We'll call this the greatest displacement, okay? We are almost done. I'm actually going to kind of skip ahead and show some other points we'll need. So we're going to want a point for this right here, this intersection actually, this intersection and that intersection, okay, to get this completed. And those are going to be some kind of weird equations. So bear with me here. I might need to look them up. But we'll call that first one D2, okay? And this one is going to be, it's 3 parentheses, and it's essentially, let's see here. Let me get some help here by actually going to this one. Cancel for a moment. Go here, go to our change parameters. And it was D1, I'll just copy it from here. But yeah, D1 minus D0, so the difference between those points, we're going to create those as circles, you'll see why when we get there, times 0.25, okay, it's a quarter or 0.25 of the way around the revolution, okay, plus D0, okay, so it's starting at that smallest or least displacement, okay, so I'm going to go back to here, and in my parameters, I'm going to plug that in for D2. Okay, so there's the expression. This is called D2, and it's going to be called let's see, first point in, how about the curve? Okay. So we're going to have to do the next one now, the one that's at the very bottom. Okay, so you can guess the only difference is it's going to be this times 0.5. All right. At least I think that's right. Let me make sure of that. Go back to my parameters. Yes, everything is the same except it increases by a quarter each time. Okay, so I can come back to here, parameters, and we're going to add another one. We'll call this one D3, and it is the same expression. So I just hit Control or Command V, and whoops, 0.5. Okay, and so this is the second point in the curve. All right, finally, we want D4. All right, same thing, except this time it is 3/4 of the way through that curve, and so it's third point in curve. Okay, great. So I've got those. All right, so let's actually get started with this here. All right. What's cool about making those, of course, we could have made this and just dimensioned it in the normal way, right? But by using these parametric dimensions, I can basically change one number and the whole thing will change accordingly, right? With the dimensioning you've learned so far, if you change one thing and you want everything else to get bigger or smaller, you have to go in and adjust every one of those dimensions, right? But this way we won't have to do that, all right? So I'm gonna make this on this plane here. And first I'm gonna put the circle representing the hole in the middle where the axle will go through, right? And so that's gonna be a 0.25-inch diameter circle, all right? I did not create any parametric dimension for that, but that's fine, all right? So next thing I need to do is I need to place that least displacement circle, right? So I'm going to put, if I remember right, I think that was what I called D0. Hit enter, and there it is. Except here's the problem. D0 is fine, except they meant that, if we look at it, as a radius. All right, that's a radius there, not a diameter. So what I actually have to do is, instead of D0, let's do D0 times 2. Okay, good, I've got that one. And I'm gonna make one more for the next one out. All right, and this is gonna be D1, again, times 2. Okay, cool, so I've got those. Let me zoom in on it. And we're gonna turn these into construction circles. So just click it and hit the X key, all right? That toggles between normal lines or object lines and construction lines. All right, cool. So now I need to place my other points. So let's go to create point, and we want it to be on this axis. Okay, we want this one to be on this axis. It doesn't look like it's lined up exactly, so I'm going to fix that in a sec here. And then we want this one to be on this axis. All right, except that's snapped to a spot, so let me move that a little bit. Trying to undo. There we go. And we're going to create another point. And let's just place it somewhere in the middle so it's not actually snapped to a spot. Okay, so real quick, let's get those lined up correctly. So we need this to be, horizontally constrained. We want this one to be vertically constrained. And we want this one to be horizontally constrained. Okay, so now those are all set. And I just have to add their dimensions, which, here we go. So from here to here, this is going to be our D2. All right, so click and enter D2. And we don't have to multiply it by 2 this time because this is more like, think of a radius, okay? So I hit enter. I have to hit it twice, but there it is. Perfect. All right, now let's dimension from, again, the center point to this point. Okay. And something's getting weird here. There we go. D3. Cool. And finally, we're at D4. So from here to here, D4. And we are about set. So I'm going to click OK. And basically we have everything we need. Let's just drop some points to make it a little easier for us. How about right there? Okay. And I'm going to okay, so I'm going to put it on that circle, so hopefully it's kind of tangent, like it's applied that constraint. We'll see here. But I need to move it so that it's vertically aligned. Okay, so good. So yeah, that followed the curve right up, and do the same thing here. Awesome. Okay, so we've got our points. So there are videos, and if this gets kind of messy, it is a little bit messy. Bring the sketch plot up, turn off your dimensions, right? You can even turn off your constraints. So basically we're going to connect the dots from here, 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 this, and this. Now I've seen in videos someone doing that with a spline. That didn't work out for me very well. I could open that up. It looks a little wonky. I saw a way with an arc, and I liked that a lot better. So let's do that. So I'm going to come to Create. We're going to do a 3-point arc, okay? And so I'm going to connect this least displacement point to this kind of midway one, and then have it go through that one, all right? And then I'm going to connect the halfway to the end and have it go through this third point, all right? So now I'm almost finished. I just need to connect the end to the beginning with a line. So I'm going to say, okay, let me finish the sketch here. And now what we can do is extrude it, and I think it was 3/16 of an inch. So I'm going to click here. I'm going to type 3/16. All right, and I have my SNAIL CAM. All right, with the parametric modeling. There's one more thing I want to do. I want to fillet this because it was suggested to me that by filleting it, it's going to make the motion work a little better when this is on like Fusion360. So I'm going to click that edge right there, and I'm actually going to make this kind of parametric too. I'm going to say I want this to be d divided by 16, or 1/16 of d. Okay, cool. So I got a nice little fillet there. Now here's the coolest part. All right. Oh no, I made my cam the wrong size. Well, all I have to do, modify, change parameters, and determine whatever size it needed to be, and change that nominal diameter. And let's see here, there we go. Change that to maybe like 2. Boom. You can see it got big behind there. Okay, so I know this is a long video, but hopefully this explains how to do some parametric modeling. You can create your own parameters. Just refer to like this table for an example. Of course, they'll look different for the different cams. But yeah, it's a really neat tool for you to be able to adjust the size of something all at once in a very easy way.